Hello everyone, my name is Adrian Balahadia and I'm a grade 9 student from St. Matthew's School. And in this short video, I'd like to present my project, You've Been Caught, a computer algorithm for detecting academic dishonesty in school written assignments. So let's get into it. The recent COVID-19 pandemic has forced students and staff to undergo online learning. And even though students are expected to complete assignments with utmost honesty and integrity, unfortunately, there has been a rise in cases of academic misconduct through contract cheating and the copying and sharing of files. And unfortunately, this dishonesty in education is growing. In a CTV News article, they interviewed Sarah Eden, an associate professor at the U of C's Workland School of Education, and she highlighted that universities across the country are experiencing increases of up to 30% in their academic misconduct cases from the initial shift to online learning. And as a student that has previously participated in the science fair, I really want to present this project that will contribute to the minimization of academic dishonesty in a junior high school setting. And I believe that providing this tool that I develop, it will not only help teachers detect this type of cheating faster, but will also hopefully would correct this type of behavior and attitude among students as early as junior high. And in this project, I use natural language processing, or NLP for short, and it is the domain of computer science that merges linguistics and computers to better understand human interaction and human text. And in this project, I applied its principles and concepts to create a cheat detection program utilizing 13 cheat indicator features with its overall accuracy evaluated in a variety of different documents. So let me describe to you the architecture of my program. So this is what the structure of my program looks like visually, and as you can see, it consists of two layers here. And generally, each document in the class list goes to the first layer, and this produces a list of students who have similar documents. Then this list gets passed on to the second layer for another more detailed feature analysis or feature comparison. Then the result is a list of paired students who are suspected of copying from each other. And to make this more clear, I've sort of prepared an example for you. So let's trace back to the first layer, or to step one here. And a more detailed, we'll also move on to this slide. So in this case, the program begins by selecting one text from the entire class list, and it denotes that selected text as student A, or the specimen. And in this case, we begin the process by choosing document read as student A. Then document read is passed on to the first layer, and we apply the delta method. And what the delta method does, what this math function does, is that it compares student A, or document read, with the rest of the text from the class and narrows it down to a list of 4 possible students that might have copied from document read, or where document read might have copied from. And the delta method, as you can see here, it computes delta scores, wherein the lower the score a document has, the higher similarity it is. So, and after applying the first layer, we get that list of 4 documents, and we pass it on to that second layer. And after the program obtains this list, it passes to the second layer, and in this case, it compares student A, or document read, to each of the 4 documents in that specific list. So in each comparison, it evaluates the document on 13 features that are related to the meaning in the documents, the sentences, and the words in the text. So in this case, it would compare document red, document red to document green, red to yellow, red to blue, etc. And in the feature analysis, some features they require pre-processing, uh, which is described more in depth in my CYSF paper. And what pre-pro and as you can see here, it's possible pre-processing function. And what pre-processing does is it removes irrelevant information in the text. So after that, in the comparisons, the program implements a point system wherein student pairs like red to green and red to yellow gain points if they have similarity readings from one of the 13 features. And if their overall final score or final counter exceeds 5 points, then we would put them in the output list, or what I like to call it, the suspect list. And please note that in testing, I modified some of the features so that each feature is weighted differently depending on if they are good indicators of cheating. For example, for example, in the paper which describes this better, some features contribute only 0.25 points to the score if they have similarity readings, while other features such as TF-IDF and word movers distance may contribute 1.5 points to the score. And also, please remember that due to the 10-minute time limit on this video, I cannot fully describe the architecture and features that accompany my program. So I suggest reading the methodology section of my paper on the CYSF website. And actually, in the following section, which talks about tests that I perform in order to improve the quality of my model, it does require a bit of more context and understanding of the point system that I employed and the features that I used. So please at least skim through that section before continuing my model using 3 test cases and made modifications accordingly. And in each test case, it included at least 3 scenarios, with each scenario including the source text and a few test documents or test samples which were labeled as either non-plagiarized or plagiarized. And the objective of the program was to ensure that the non-plagiarized examples were excluded from the output list, while the plagiarized examples should be, of course, included in the output list. And by testing and modifying the certain threshold values and the point system, I was able to improve the output quality of the program from 24% to 64%. And some of the sources of where I got these test documents, well, unfortunately, due to confidentiality uncertainties from teachers, I was not able to obtain many real junior high school texts. So to compensate, I researched some examples online. So looking at the first test case scenario, I set all the point values for each feature, and by point values I mean points that are awarded when there is a similarity reading. So I set all these point values to all of them, all the point values for all the features to +1, and the point threshold of the final counter to 4. And what I found was that some features were were better were better cheating indicators than others, such as the TF-IDF shown in figure B here. And additionally, I also concluded that I need to reduce the point values for some features that were not so good at indicating cheating. For example, in figure A, a document may have the same amount of sentences but could have entirely different topics. Therefore, in the second case scenario, I reduced the certain point values for sentence related features and word related features. I ran this 3 sets of test documents and found that the accuracy overall was 90%, but the overall final scores and the final points were a bit still too high. Therefore, in test number 3, some features points values were ranging from 0.25, 0.5, +1, and some having +1.5. And additionally, in test 3, I included some paraphrasing examples, and the final accuracy was 64%. And the reason why this is 64% is because a program could not successfully identify the paraphrasing examples. And the reason for that might be that the paraphrased examples had much different words and much different word use. In conclusion, despite having made these modifications to my program, I cannot say that it is ready for real school implementation. And it is because of the lack of test documents that I believe that the prototype still requires further testing and that it still presents certain inaccuracies. Thank you for listening, and it's been a pleasure to participate in CYSF 2021.